Fizzbuzz, I hope you're ready. And luck sounds good. Spetch, congrats on the first. Who am I kidding? Fizzbuzz was born ready, but um, just make sure I have everything in order. I think I do. Let me just make sure the thing that's on the screen now isn't relevant. Hang out in text chat. Oh yeah, that's fine. No worries. Okay, yeah, YouTube's up. All right, I'm gonna hop in the voice chat. And then I guess bring in the first question. Femox will just hop in once he's ready. Meal prep like 18 breakfast burritos. Ooh, it's a nice place to be in life. Freezer full of burritos. Okay, so we ended last time on number 4. I think we basically got through it. And so just the next one I had in queue was number 5. Um, Slim, thank you so much for the raid. Welcome in, everyone. I hope your stream was good. I peeped it for a little bit. Not fucking many. God, there's a long delay on that. That's too early. Uh, thank you so much for the raid though. Um, Inspectory with the 2 years now. Thank you. And yeah, I'm slightly sick. I was much worse a few days ago. I streamed yesterday and it was a lot worse. Or like my voice sounded even weirder. But I'm nearly back. Hey, $5.
Hey Don, how you feeling?
Better at least. Not completely
I
back.
think you sound better than you did yesterday.
Yeah. Oh my gosh, and Ben, thank you so much for the Prime, dude. I hope you've been well. It's been a minute. Um, I'm growing. Oh, I thought I meant like my height. It's like I don't think I'm growing, but yeah, the channel. Yeah, thank you. um, it's good. It's good to hear from you, dude. I hope you're well. And yeah, Fenbox, I think I'm with you. It'd be too dumb to eat all 18 of those burritos at once. So I did put the link to the Excalibur in that like text chat for the voice chat.
Yep, let me find it here.
You know, I meant to do a pinned message. Oh my god, I was supposed to say we're reading out of Hartle by James Gravity. Oops. Okay, and then pin that. There we go. It's him, John Gravitation. Yeah, he invented gravity. Hey, Central. Better, yeah. Not good completely back, though. Thanks for asking. Okay, so for number 5, calculate the area of a circle of radius r measured from center to circumference. Okay, it's I'm a little bit weirded out. Like, what else would the radius be? Wait, is this not? Am I not drawing? That's not good. Uh,
Looks like I'm drawing.
oh, I see the culprit. No? Okay, your drawing works. Why doesn't mine? That's my mouse. There we go.
Now you're good. Yeah.
Okay. So I wonder if there's going to be a different notion of radius somewhere later on, but like the thing in parentheses is kind of weird to be why it's there.
Well, don't they mean the curved radius? So the circle's kind of, the top cap of a sphere, and they're talking about that arc radius.
I guess that's what I was assuming, but they say the center. Like, is that the center of the sphere? I guess the center of the
No,
circle.
the
But
circle, yeah.
yeah. Okay. In the two-dimensional geometry, the surface of the sphere of radius a show this reduced to pi r squared when r is much less than a. Yeah, I know. I would have been less confused if they just removed the parentheses, I think. Or like, I feel like I already understood it, but then like reading that, I was like, am I missing something? Uh, okay, so the area. I assume we're going to need to build this up from integration. Um, and
It's
so,
basically a spherical cap.
yeah.
Yeah, integration, right? Okay.
Um, and so let's just say like the circle is somewhere, like we want the area of that circle there. Uh, I think basically our theta is going to go from 0 to something we can calculate that depends on the radius of the circle. And then like the phi would be 0 to pi to 0 to 2 pi if I use the physics convention for spherical coordinates. Area of a cone in a sphere? Oh, I'm sure there's a connection there, but I haven't think I've seen it before. I think at least the intent of the book is to get us to integrate something. Um, oh, I'm sorry, Fanish. I'm not gonna have time to do a show until during the reading group. I'm gonna refund it for now. If you want to do it in like 2 hours after the sober, though. Um, and so like we could, I guess, think about one little patch in the area of that thing. Uh, maybe that's gonna be a little bit too small to properly draw on. Um, oh, you know what? The book did some calculation that'll probably help with this. Like, it's the distance, it's the extra distance you go if you have plus d, like, if you go from theta to theta plus d theta and phi to phi plus d phi, what the overall distance increases, we might need that.
Page 23. Line element for a sphere. Is that going
Yeah,
to
and then
help
I was
us?
looking at the
We
figure
need
on the
to.
next page. But
Yeah.
oh yeah, I guess the line element. Um, or maybe we don't need that exactly. But maybe the things they calculate on the way are going to be helpful. Um, guess looks like Fizzbuzz is off to the races doing something. um, I guess I chose that's what the answer is gonna be, but I guess I'm trying to like figure out how to get to it. Um,
Yeah, so the arc length. Yeah, okay,
DA.
I think I understand it.
Uh,
So in your sphere here, that's A.
AD theta.
This is R
Oh,
here.
okay. I see it. um, the figure they do, they make the exact same type of patch that we have. They calculate a different thing from it, but we can use the exact same measurements that they got. Like one side of their patch is AD theta, the other side of patch is A sine theta d phi. We can just multiply those two sides of it together to get the area.
Oh, that's a nice shortcut.
Yeah.
Yeah,
Instead of going back through it all for ourselves.
very good. A squared
Uh,
sine theta d phi d theta. Yeah, okay, that's exactly what Fizzbuzz
AD
is doing.
theta. Yeah. A sine theta d phi.
Yeah, so theta has to go from 0 up to R over A. Yeah, that makes sense.
0 to r over a.
Yeah, because in this
Ooh.
picture, here's our theta here. So R is A theta.
Oh. Uh, Donut Ales? I'm saying that right? Uh, thank you for the follow. And Waffle, hey, I hope you're doing well. R is equal to a theta. Yeah, okay, yeah. And then I'm just looking through the actual steps of the integration here. Okay, yeah, so we end up with 1 minus cosine r over a, and I assume we do an approximation, yeah, for cosine. Oh, wait, is this supposed to be a theta? Or is that actually... Oh, no, it's big O. I see. Okay, and so that's doing the second part of the question, that it's about pi r squared when r is much less than a. Okay, cool. I think I'm good with that then. Noish. I guess I'll bring in number 6 here. This one has a B, so it might be weird. Bring it in just below. Okay. Consider a sphere of radius A and on it a segment of length S, a line of latitude that is a distance d from the North Pole measured on the sphere. What is the angle between the lines of longitude that this segment spans? Uh, I read the words, but I didn't understand them. Sphere of radius A, segment of length S of a line of latitude. Okay. So this is like a segment of the circle, the type of circle that we kind of just drew in number 5. So to have a segment like that with length s, distance d, the angle between the lines of longitude. So we want, well, I guess maybe instead of, we basically have a triangle, I guess. Isosceles triangle.
Yeah.
Well, I want to use trig here, but I don't know. I don't know if that still works on the surface of a sphere. Trig does not work on a sphere. That, yeah, that makes sense. It might. I mean, hmm. I was wondering if like we would want to cut it in half like we would with a regular isosceles triangle, but I'm not sure that it would be helpful.
Let's, if we make a circle, um, if we take that arc S and extend it to make the whole circle um, a line of latitude, then we should be able to find, let's see, in terms of D, we should be able to find the whole length of that line of latitude, I think.
Yeah, we probably could. So we know there's a set of trig stuff for spheres. There probably is. Waffle, yeah.
In fact, they did work this out on page 19, a ratio of circumference to radius of a circle. Equation 2.5.
Hmm.
So I'm thinking of extending that S to make a whole circle, and it'll be S over D is 2 pi sine D over D over A. Is A the right letter? What letter? Yeah, A is the right letter.
I wasn't following all those letters you were throwing out, but if you want to write it out or
Yeah, let me write it out. C over R. So this is just the formula from the book.
Mhm.
2 pi sine R over A over R over A, where R is the radius of our circle, which in this case would be D. So I'm thinking of like
Right.
extending this around to make a circle. So this is 2 pi. And A is the radius of the Earth, right?
Yeah.
Did I write this right? And this is C over D in this case, right?
Hmm.
Okay, so let's see. Was this a good place to start? So we're trying to find this angle up here. So we got the whole circumference then. So if I multiply the D
Oh,
over, I get the whole circumference.
well, now it's just like the arc
Yeah,
length for a part of a circle, right? Like we have the entire circumference, and we
yeah,
know
so
if we went all the way around, that'd be like two, like that's what the 2 pi is.
Yeah,
Instead
that's
of
where I
2 pi,
want to
we just
get
have
to.
theta, I guess.
Yeah.
Or
So could I
d, or
say S
whatever.
over C? Yeah, what do you want to call it? Theta?
uh, I
How
feel
about
like both
alpha?
theta and v are bad because they're already
Let's call it
used.
alpha.
Yeah, alpha.
So if I say S over C is alpha over 2 pi, I think that's good. So alpha is 2 pi S over C. Which is 2 pi S times. So the 2 pi's cancel and we get so let's see, does that make sense? D over A is I guess that could make sense.
Units don't quite work, but this looks basically right, Fizbuzz says.
Yeah, I was looking at the units too, but I'm wondering if is it another case where I want alpha to be radians, D over A is dimensionless, and S is like a length, isn't it? Where's my mistake? S over D on the right hand side, is it? Oh, did I? Oh, I lost my D. Oh, did I lose the D here? Yes, I didn't bring the D over. Thank you. Because there was
Oh,
D over D.
yeah.
I need a D times D there? No, it didn't work. Over D.
Uh,
Because I put the D there. Yeah. Thanks,
okay.
Fizzbos. Yeah, there's
Yeah.
a D down here. Sorry, I was going a little quickly. So S over D.
D-less.
S over D.
Nice. Um, it's kind of an annoying formula, to be honest. I guess the D's could technically cancel, but it almost kind of looks nicer without them canceled. Um, okay, there's another part to the question. Is this angle greater or smaller than the angles the segment would subtend at the same distance on a flat plane? I'm betting it's a bigger angle than a flat plane. I'm just trying to visualize it.
That's the thing we were talking about last time a little bit in that box where it was talking about yeah, it says if the geometry were flat like a plane, the angle theta subtended by these objects would be P over D. So they're using P for sort of the S. They're using P where we're using S, I think. Page 17 has a picture just like this.
Oh, this one.
Yeah.
Right. Hey, G-Hive. Hope you're well. Um,
This is that one I was talking about last time. I didn't quite follow how they did it.
yeah. Actually, yeah. So it's a number. It would just be s over d. The number that we're multiplying s over d by is presumably more than one. Is d over a more than one? No, I
A
don't.
number
Not
divided by its
necessarily.
sign would be bigger than one. Yeah. A number divided by its sign. If it's a small,
Number
d
divided
over
by
a is
its.
kind of small, then the sign should be under. So the if you flip it, it'll be big.
Okay, sine is always
I'm good.
less than
Yeah.
x or equal to. Yeah, around there. Okay, I like that. Um, okay, so yeah, I think we can say it's greater. Okay, interesting.
I still don't know why s equals d times alpha.
Y s equals d
When it's
times
well, I
alpha.
guess it's well, I guess the point is it's not equal to it, is it? Because we've got this d over a divided by sine d over a in front of it to make the equality not hold. But I still don't understand. That's what I was saying last time. Like, how did they say the angle theta subtended by these objects would be p over d? I guess I didn't quite understand where they were measuring. So if the d is if that's an isosceles triangle in that picture up the top, and if the two sides are d and the base is p, it's not really true to say that theta is p over d, is it?
Um, yeah, I wish that they. I don't quite know where d is in the picture.
Yeah, I know they didn't show it, but I figured it was from the North Pole to the two ends of that object they were talking about.
No.
I think when I was messing around with it on a piece of paper, I tried it two ways. I tried it with an isosceles triangle with the two sides being d, and then I tried coming down the middle and saying that the straight line right to the base would be d.
Hmm. Yeah, I guess it these should be the sides of the isosceles triangle. They really should be labeled though. It doesn't seem phrased that well. Hey, color code.
Well, I think we're good.
Yeah. All right. Below, I'll bring in number 7.
Yeah, the next one looks interesting.
Yeah. Seems like we're getting into it. Consider the following coordinate transformation from familiar rectangular coordinates x, y, leaving points in the plane to a new set of coordinates mu nu. X equals mu nu, y equals 1/2 mu squared minus nu squared. Is that nu? I'm pretty sure it
Yeah,
is. Okay, yeah. Sketch the curves of constant mu and constant nu in the xy plane. Um, Okay. So if mu is constant, then nu and x really aren't all that different. It would just be like a horizontal stretch or compression, is all the effect that mu would have if it's not one. Uh, and so I think it's just gonna be a parabola facing down. X, Y. And the roots would be at plus or minus mu. Difference of two squares. Uh, or uh, maybe I need to actually write this out. 1/2 mu squared minus, it'll basically be mu squared nu squared. So I guess plus or minus 1.
Wait a second now.
Or wait, no. Or I'll be dividing it. Is that? No, wait, oh, yeah, I'm doing the wrong substitution. We're getting rid of nu. X squared over mu squared. And mu is just some constant here. I think I like this more. What is that? Should be squared. I'm getting over being sick. Collar cone. I don't know. So, does this make sense to you? Like, I'm just thinking if mu is constant, then
Yeah,
like,
yeah, I
okay.
follow. I follow what you did. I'm surprised. When I looked at it, I thought we were going to get something. It just looked like we were going to get hyperbolas. I don't know why
Uh,
I immediately thought it would be there'd be hyperbolic things going on.
I don't know. I don't know like what to think of it. So if nu is constant,
Actually, this is kind of weird, isn't it? Because if you we're not just shifting that parabola up and down because we're scaling it as well. Like if we add, like what happens if we double the mu now?
uh,
The vertex moves up. The vertex moves up by a factor of 4, but the roots get pulled in, don't they, towards? No, they get pushed out. Which way do they go?
they're coming. Bigger mu means they're getting pulled in towards the origin.
Are you sure? That's what I
Circle
thought too, but
0.
now I'm not sure.
Uh, mu squared over 2. I think so.
So you're saying they're getting pulled towards the origin, right?
Yeah, it's the
Yeah.
vertex
Okay.
getting pushed
Yeah.
up and they're coming inside.
Yeah.
It's kind of like it's like a sequence of functions that like it would converge to like array that points down the
Yeah.
y-axis.
Yeah. Yeah. And if we go the other way, if we make mu small, we're going to flatten this thing out and make it really wide.
Yeah, I guess like a horizontal line nearly. Maybe it's not. I guess it wouldn't quite get it to be like horizontal line, but it'd flatten out a lot more. Can you be able to spoiler an image in Excalibur? Oh, are you like a? Oh no, okay. You're just not. Yeah, I don't know if there's a way to do that. Okay, I won't look at that until you say to look at it. If new is constant, x is still like move it far away. Oh, okay. X is still like basically like linear. It'll only ever like changing new would only give like a stretch or compression. Y, I mean, that's just gonna be a parabola again, but maybe facing up this time.
Ah,
I guess the x equals mu nu is kind of convenient for the constants, for like the case where you look at each of them being constant.
actually, yeah. That's just yeah. The roots aren't the roots just plus or minus mu squared. Sorry, I'm still looking at the first part, the first graph.
Uh,
I think we got a mistake there
Only
because
mu
we need the
squared?
x-intercepts to be.
Oh,
We don't want them in terms of x. I
yeah,
think it's just. I think
that
it's
doesn't make
just
sense to
mu
have an X in
squared.
there, does it?
No,
um,
I think that's just mu squared because if we look at what you wrote, if you plug in x equals mu squared, you get mu squared minus mu squared, you get y equals 0, right? Right here. So
yeah.
yeah, so regardless of what mu is, x is going to be mu squared. I had to think twice because I think I saw the graph that FizzBuzz pulled over, and they're not getting pulled in towards the center. They're actually moving out, those
Oops.
parabolas.
Yeah, I don't know what I was writing there. Uh,
It was a nice graph. It makes me think of, I don't know, like when we were doing equal potential lines or something.
oh, yeah. Uh, it is just mu squared. Okay, I shouldn't try to do mental math today. Minus mu squared and plebabite. Thank you for the follow.
Okay, cool. So let's think about constant nu.
Okay. Um,
Wasn't it
Well, this
just
should
the
be the same
same
thing,
thing? But
just
yeah,
vertically
but it's
flipped,
negative, right?
I
Oh,
think.
yeah, good, good.
Uh, okay. I guess that's what we want then. Um, for part B, we got to find the line element for this new set of coordinates.
Here's where my Calc 3 has a chance to fail me.
Yeah, I'm just thinking about this. It's like we want to get the total derivatives, but when things are like this in a differential form, I'm trying to work out how exactly we express these derivatives.
We just say dx equals mu d nu plus mu d mu.
Oh,
That's all I have to say.
yeah,
And then dy is 1/2 of 2 mu d mu minus 2 mu d nu. Yeah. And then maybe we got to square both sides and hope for the best.
that yeah will be a little annoying. Uh, so we're just gonna get
Oh yeah, the 2's will cancel. That's nice.
is it like mu d mu minus nu
Yeah.
dv or d nu?
Yeah.
Okay.
Yeah. Looks good.
Okay, yeah, and then I guess like you say, we're gonna have to add them and square them, or square them and add them. Uh,
And then, oh, the cross terms will cancel, won't they? Will they? Yes. Nice.
okay.
That's good.
Mu squared d nu squared plus 2 mu nu d mu d nu plus nu squared d mu squared mu squared d mu squared. It's 2. Oh, okay, so these are the cross terms you were saying. And cancel.
Hey, he did spoiler it.
Oh, yeah, I saw that. I was like, getting closer to Fizzbuzz's image. Hey, Sabby. I thought I put it in the title at least, but we're talking about chapter 2 right now. This is our second meeting for the reading group. So we have 2 mu squared. Oh no, wait. We have no common terms. I guess we should group it by the derivatives, I guess.
Yeah.
So mu squared plus nu squared d mu squared plus, and then same thing. Okay. I guess that's our line element.
Yeah.
Do the curves of constant mu and constant nu intersect at right angles? Ooh. Huh.
Well, okay. Let's see if what can we say? If mu is constant, I mean, if mu is constant, then the d mu will be 0.
Oh, that's a good. Okay. Right.
And if the nu is constant, the d nu will be 0. So maybe we can, let's see, but then what do we do? Oh, okay. So we can look at ds d mu and ds d nu, maybe. That doesn't tell us what angle it's going, does it?
That I mean, what you just said might be the answer. Where like, if d mu is 0, we only get changes in nu. Well, I'm wondering if the only situation where they wouldn't be at right angles is if we had d mu times d nu. If they were, or like if we didn't get that cancellation, then I could see it
Oh,
not being orthogonal. But
oh,
since like d nu being or d mu being 0 wouldn't affect any of the d nus, it seems okay.
but doesn't this line element just tell us we're just kind of it gives us a metric to measure in the direction we're traveling, right? But I feel like it doesn't tell us which. I feel like it doesn't guarantee that those two unit vectors, like the nu and the mu, would be at right angles, though. Maybe it's
Yeah,
because that is it because the coefficients were the same, mu squared plus nu squared times both of these things, so it still doesn't prove it.
fair. I could even have written it, or I could have like factored the coefficients out even. Wait, it's not right though. Are aren't I? This feels wrong when I actually write this. I guess it must be right. Never mind. Okay, yeah. Just something about that the waivers even know. This is fine. Hey, Ozane. Or, yeah, Ozane.
Hmm. So we pick any point in the plane, right? Any point x, y. And well, first of all, if we have x and y, if we have a point x, y, then the nu and mu are unique, right? So these parabolas that we drew are gonna cover the whole plane. So if we pick a point x, y, we want to think of the two parabolas, the upside down one and the right side up one, that go through that point. And then we need either like tangent vectors along those parabolas or unit normals to the parabolas, and then we can do a dot product and show that either the dot product zero or not zero.
Yeah, that it'd be nice if we could get a dot product in here and show
Yeah.
that it's zero. Hey, Pixum. And is y plus xi equals mu plus nu I squared over 2. Oh, there probably is a, a complex variables thing like that. That does feel familiar for some reason.
So if we go back to what you did in part A,
Mm-hmm.
so for part A, the first one, you got y equals 1/2 times mu squared minus x squared over mu squared. So, I mean, that means we could get a vector at that point, right? We could say a vector at point xy is, let me think. It's not what I want though. I don't want to know where I am. I want to know which way I'm going. Oh, well, let's just differentiate. If we take the derivative of that, we get dy equals something dx, right? There we go. And then we can find
Oh,
dy dx out of that.
oh, are you saying like the tangent lines to these two parabolas are perpendicular? Or
Well, I don't know.
no, that
I
depends
don't
on
know
mu
yet, but
and nu.
I feel like if we take this and differentiate it to get dy and dx, and then get a dy dx out of it, and then if we take this one down here and differentiate it to get a dy dx out of it, and then maybe put them together, but at some point we have to make sure we're at the same point. Seems okay. Does that sound right?
Uh, I don't see
Let me
where
write it down
that
and see.
is going.
You do or you
I
don't?
don't, because
Yeah, it might not be going anywhere.
it's like, I have a hard time if there's gonna be something involved like setting them equal to each other or something like that. Like only one of them is supposed to be constant at a time. The other one is still varying. I guess
Well, yeah,
maybe
but
that's not important, but
I mean, that's true. That's true. But for any point, I think in any point in the xy plane, we're going to be on one of those parabolas of constant mu, and we're simultaneously going to be on one of those parabolas of constant nu.
hmm.
Oh, that comment came out nice. Wow.
Why do people think of birds as being carefree? Because they don't appreciate the gravity of the situation. Hey, Mega.
So mu squared dy dx plus nu squared dy dx is 0 if it's the same x, right? If we, yeah, this is looking good. So is this true? X equals minus mu squared dy dx and also equals nu squared dy dx. I don't know. I'm out in left field a little bit here. If I add these together, I get nu squared plus nu squared plus nu squared dy dx is 0.
I don't know what this tells us. I'm gonna be honest. Oops. Hmm.
Uh, Maybe it'll make more sense if we, okay, so x is nu times mu. So if we took this, if we took that and plugged it in, maybe that's better. I'm stuck in a world between news and mu's and x's and y's here. But this seems promising now. These are negative
Oh,
reciprocals.
okay. That's something.
So now, so is this valid? I feel like we fixed an x, right? Well, I guess the point is it doesn't matter what x is. If x is nu times mu,
This feels valid to me. I'm sure there's another way. And probably I doubt it's like the intended way, but I feel like that should work. You can stare at the metric and conclude it.
a secret way.
I mean, it's I'm just imagining how like I have a very hard time putting it into words, but this oh, I mean, never mind. No,
Oh,
I don't know.
Well, Buzz says exactly what you just said, Don.
Yeah, it has to be d mu d nu term in the metric. Okay, yeah. Because like I was staring at like how they like just how like spherical coordinates work and like you can just kind of freely increase theta and not increase phi at all. There's like no problem there. There's like some different scalings that happen if you increase one versus the other, but you can like fiddle with them independently. But I know I
Yeah,
it,
I see what you're saying,
yeah.
but 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 you can have a but you can have a set of basis vectors on the plane that aren't orthogonal, right? Like I could take I as one of them and take I plus j as the second one, and I could use I and I plus j as a basis for the whole plane, and so okay, so what does that mean? Does that mean you're telling me that if I tried to get a ds squared using that, I would have to get a cross term between those two?
Uh, this was a saying, yeah.
Okay, I'll take your word for it.
I'm sure we could work out the actual geometry problem there for the distance between 2 points
Yeah, I
with
mean
those
that seems like an
coordinates.
easy one to set up. All right.
Okay,
So that was
it would be easy
that was a
for
telltale sign then. So when we
okay.
did all that stuff in part B, we kind of we could know that uh all those lines of constant nu and constant mu were going to intersect at right angles.
Yeah. Okay.
Now we need a circle.
Yeah. Circle of radius are centered at the origin in terms of mu and nu. So unless I'm probably not right. I want to say x squared plus y squared equals r squared and then just substitute the coordinates.
Yeah, that was what I was thinking.
Okay. So I don't think you can. There's not like a thing you really would integrate to get the formula or like the equation for it at least. So maybe that's okay. Uh, Going down below here, circle of radius r. X squared plus y squared is r squared. X is mu nu squared. 1/2 mu squared minus nu squared. U squared minus nu squared. Well, that does not look like an R. Phobos, hello, good day. Two parabola intersection at right angles is also correct. All right, the thing I got tripped up with the parabola thing is that one has mu and the other one has nu. Does this R need to be transformed? Or like, that's the thing that's kind of worrying me is I guess it's just an arbitrary number, but like,
I say leave it as it is for now.
okay, yeah. Um, it might be worth multiplying this out. It might be able to get factored again, I guess.
Yeah. Oh, yeah. Let's multiply by 4.
Uh,
'Cause if you multiply by 4, that -2 in the middle will turn into a +2 when we combine like terms.
because it's about to become a -1/2. So then after we combine like terms, it'll be +1/2.
I was just going to clear the fractions. I don't like fractions. I just multiply by 4 and just kill them.
Oh yeah, okay. We can do that. Uh,
Let me
we
do it
do
on the
multiply
line
3 by
above.
4. Are we getting a 5 here then? Or no, it's -2. So +2. Okay.
Yeah.
Well, maybe I'll bring the 1/4 that or the 4 back to the other side that in front because we can factor this.
So mu squared plus v plus nu squared is 2r. Is that right?
Oh, so we square root
Plus
everything.
or minus? I guess it would just be 2r. That would make sense. We don't need to keep the negative solution, right?
Oh, I guess. Well, just one of them could be negative and not the other, though, right? We'd have like four cases, not two cases for the plus and minuses. No, that doesn't make sense. A negative can equal a positive. That's weird. I guess yeah, this is only positive.
Yeah, assuming the r was positive in the first place.
Oh,
So we had x squared plus y squared is r squared. We get nu squared plus mu squared is 2r. So a circle of radius, what?
that's kind of crazy. I guess so. Yeah.
So if either one of those was 0, if mu was 0 or nu was 0, x would be 0. Okay. And then 2. Well, what would we get? Y is the other one squared over 2. Does that make sense?
Are you like checking
I'm
it for
trying to
values?
visualize I'm trying to think of the graph of a circle in the XY plane. And I'm trying to look at the north, south, and east, west points of it to see if I can work out what's happening with nu and mu.
Hmm.
I wish we were just saying u and v. I know.
Yeah. Yeah. I have no idea how to visualize this.
So what about this point right here? Um, if X is 0 and Y is R, so X is 0 and Y is R. Oh, what the heck? What do we get? 2R's. We get mu squared is 2R. So it works. So let's think about that. That's R square root 2R0.
Miss Lurk. All right. Thank you, Fizzbuzz.
Uh-oh, Fizzbuzz is leaving. Uh-oh. Now I'm
Yeah.
going to feel very nervous.
Now we're in trouble.
I know.
This the 0 minus R point should be the same thing with the negative, right?
Yeah, but so I'm trying to think of like X, Y to mu.
I think it's the same circle, or I think it's like the points are getting rotated around, which would
Yeah,
be a cool connection with Fizzbuzz saying like the complex variables thing before.
yeah.
It's also getting scaled, but yeah, like tracking your point the 0R as it gets transformed to root 2R0. It's like we've gone around like 3/4 of a rotation. Whereas I assume that's what's going to happen. Maybe other points get rotated by different amounts somehow. They shouldn't.
Yeah, what, like a 90-degree rotation? Is that what it is?
I like
What's the
negative 90, I
scaling?
think.
Yeah.
If we do it for the point like R0,
Yeah, good. Let's try that.
uh, a bit messier. um,
I got to practice more writing with tablets. I'm just not good at it.
oh, did you finally get one?
I'm using a little Wacom thing.
Okay.
And it's
Yeah,
okay. I
mine
have an
took me about
iPad. I
getting
don't
used
really
to.
know how to. I don't have a stylus for the iPad, but if I get
Oh,
one, maybe that'll. be easier to use.
Yeah. Actually, they might not be getting rotated by the same amount. Because I think for r comma 0, we're not going to get 0 for
It's
either of the coordinates, as far as I can tell.
No, you know what it's coming from? It's coming from a 45-degree line. Because when x equals plus or minus y, no. When nu equals plus or minus mu, we get y equals 0.
Mm. Oh, yeah, sure.
Yeah, so these 2 points, when x is plus or minus r, those should come out to be on a like a be rotated by I think 45 degrees. Well, that's not good.
I guess it's maybe wishful thinking to think they would all be rotated by the same amount because, like, I feel like you need things to not be squared for that to be true.
Right.
Oh, okay. Uh,
Well, anyway, should we try part E?
uh, yeah.
Calculate the ratio of the circumference to the diameter of a circle.
Kind of interesting. Like ds squared has a mu squared plus nu squared inside of it.
Yeah. So if we're on a circle, can we set that equal to 2r
I would think
based
so.
on
Yeah.
part D?
Uh, Presumably we have to do some kind of integral to get the ratio. Or yeah, and but how do we set that integral up?
Could we just do the same kind of trick they do in Cartesian where we sort of write d mu squared plus d nu squared as 1 plus d mu whole thing squared times d, like once you take the square root of both sides, you know how they do the arc length formula?
Oh, yeah. I'm still not sure about the bounds.
Yeah. Is it 0 to 2 pi? Doesn't feel like it, does it?
No, it'd be like minus 2r to plus 2r or something like that.
not d4, d mu. And this may be 2r. This may be a constant in here.
uh, yeah.
So oops.
What is dv d mu though? Is that our issue? Oh no, we can figure that out from the equation of a circle.
Oh yeah.
Okay. Let me put a little e there so we can track what this is for. U squared plus nu squared is 2r. Then we want dv d mu. Okay, so 2 mu plus 2 nu d nu d mu is equal to 0. Implicit differentiation. Oh, this. Yeah, that's good. That's how it looks for normal x and y coordinates, or something like that at least. Oh, we want to get rid of the nu though, don't we? I guess that's what we would need to integrate with.
Okay, cool. What are the bounds? What are the bounds? You're right. What are the bounds?
I think it's just minus 2r to plus 2r. I don't know what else it could possibly be.
I guess so. Wait, should
I
it
wonder
be
I'm only going to get half the circle with something like this, though.
minus the square root of 2r to the square root of 2r?
Uh, oh.
Oh, and
Uh,
then oh yeah, and then like you said, maybe double it.
I think I'm on board with that square root, and we probably need to double it because of the square root business.
Or maybe we should have gone to polar coordinates in the land of mu and nu.
Um, hey,
Hey, it's
Gold.
Dr. Gold.
Put a bunch of 1 over c and 2 pies somewhere. Is that how relativity is done? I think we can handle it then. Okay, so we're integrating ds around the circle. Hey, Thunder might as well add a Lorentz factor, yeah. So root, like I guess we're gonna say that root u squared. Oh my god, if we're saying that mu squared plus nu squared is 2r, then we're gonna have a root 2r here. So to
Yeah, we
make
should
the
have just
integration easier.
let them be root 2r sine alpha and root 2r cosine alpha, maybe. But we're almost done. I think we're almost done here.
Okay, I'm not sure where that would or where that's like. I still think what you're saying with the polar coordinates. I'm not sure where those like would come in. Is this? This is probably annoying to integrate, isn't it? uh,
No, because if you clear the fraction, let's see, mu squared plus 2r minus mu squared. So the mu squareds cancel. And then bring the 2r and we get, I think that whole integrand is just 2r over mu, I think.
let's keep pushing. So we can factor. Oh, I guess to get a common denominator.
Yeah.
Oh, okay. I'm trying to factor whatever mu squared out, and it was getting weird. Yeah, we should just get 2r over mu squared. Okay.
Yeah.
Yeah, that's not so bad.
So we're getting a logarithm.
So we just chop off the root, and 2 times 2 is 4. It's really radical ideas. And it's just going to be the integral of 1 over mu, so we can make that ln. Oh, wow. The ln out of left field.
Yeah.
Uh, 2r. There's going to be some identities that are going to happen here. This is going to. No, it's just zeros.
I hope it's not zero.
0 is an identity. Well, that sucks.
How do we check FizzBuzz's answer for part D? Can we unspoil the spoiler?
Uh, yeah. Or I don't know
Do I
exactly
just
what
erase
it
it?
is he posted. Oh, okay, yeah, he puts off everything. So for part the oh, he put the little box over it.
Yeah, can we just grab it and move it? I don't know.
Oh yeah. Oh wait. Okay, no, that matches, right? We took the square root, but that's okay. Hopefully.
Nu squared plus nu squared squared is 4r squared. Okay, that's what we got. Okay. All right. Well, I just wanted to check. So far so good, I guess. Except I think part E we're not got something wrong. What if we tried polar instead? Because sometimes sometimes I know I've done these integrals and you get 0 and you're like, this is not supposed to be 0. Maybe if we went to polar coordinates. I'd still like to know where the mistake is though.
Like getting conversion between these coordinates and polar coordinates, or what?
Yeah, well, I was thinking instead of trying to integrate d mu, we change it to an integral d theta, and we let mu be root 2r cosine theta and nu be root 2r sine theta. Is it going to help? I'm not sure.
I don't know. Someone chat GPT. Never.
What do these give me? So d mu 2r sine theta d theta.
Does a theta like this always exist though?
I don't know. I don't know.
We can see
I'm going to
what
soldier on
pops
with
out
it.
here.
I'm going to soldier on with it for a second and
Yeah.
see what happens. So if I square these and add them together, what do I get? 2r. We'll get 2r d theta, right? So d mu squared plus d nu squared equals 2r d theta squared. I think that's right. And then, so what are we going to get? We're going to get and what else do we get? We get mu squared plus nu squared equals just 2r, right? So then ds equals 2r times 2r d theta squared. Is this right? If this is correct, it's much simpler.
Uh, should be ds squared equals that?
Maybe, yeah. Was it ds squared? Yes, yes. Good catch. Okay. Well, that's easier. Ds is just 2r d theta.
This feels too good to be true.
Yeah.
It'd be nice.
Okay, here's my question. X and Y and mu and nu, all these 4 variables are coexisting peacefully in a plane, aren't they? In other words,
Uh,
I want to think that I want to think that all our curves are living in a two-dimensional flat surface. I think that's true.
the curves are in a two-dimensional flat surface?
Yeah.
Uh,
All those parabolas that you and Fizbos came up with, I think they're all in a plane. We're not on the surface of a sphere or anything.
yeah, okay, true. It's just a coordinate transform.
So if that's true, then I think regardless of oh yeah, I don't know. I want to say I can use a polar transformation then, just like I could if it was rectangular coordinates.
Yeah. Okay, that's
Maybe it
fair.
doesn't work. Yeah. Yeah, maybe it doesn't work. Maybe no. Well, we did say they were, did we say they were let's see, curves of constant mu and constant nu intersect at right angles. Yeah, I don't know if if treating them as cosine and sine of some angle, I don't know if that works. I've gone this far, I'm going to finish it. So deep. So 1s would be 2r times 2 theta.
Oh wait, so we are actually maybe what you put is okay. We are supposed to get the regular circumference of a circle. I'm getting a little too in the weeds of we should get something weird. But it is the same circle in x and y coordinates and mu and nu coordinates. We should still get 2 pi r for the circumference. Hey, Lucas.
Well, I got 4 pi r.
Uh, you do.
Oh, but wait a second. Wait a second. So, okay, that's the circumference is 4 pi r, but we said the radius was the square root of 2r, wasn't it? There's that.
The radius is the square root of 2r. Yeah. Or maybe.
Ratio of circumference to diameter. Oh, diameter. Two root two. So the diameter would be 2 root 2r.
I I wanted to avoid this, but there's always um the terrible thing to do, which is to set the integral up in Cartesian and then convert it, or at least I tried to convert it. Um, how terrible would that be? You know, it's funny. It's basically going to be the same exact integral. I think, or that can't be great.
I didn't understand why we had a logarithm. That seemed weird.
Yeah, like we definitely shouldn't have a log. The point of our arc length, it is 1 plus dy by dx squared square rooted, right?
Yeah.
Okay, yeah. Oh, there's a discontinuity. Well, yeah, there is a discontinuity with 0 when we divide by x. I don't know if that's what was breaking the integral.
The discontinuity?
Yeah, that it would get us negative infinity though with the ln. So I don't know if that's breaking it even more. We can't completely sidestep it. I was gonna say we could multiply by 4 and do it with different bounds, but no.
Wow, we're doing something really wrong here.
I think we're doing something only slightly wrong, and that's annoying me. Hmm. Uh, that's what I was trying to do before color cone, but I think I'm running into the exact same
Yeah. Yeah, that's what we're
issue
trying to
that I was
do.
doing in the other problem. Yeah, where like it's gonna come out to be 0.
But if we do, okay, so it comes down to square root r squared over x squared. Can't we say that's r over absolute value of x?
Yeah.
Is this going to save us here? So let's see. So maybe when x is, should we get an addition instead of subtraction here? Maybe, regardless, I don't think we should have logarithms in here.
Yeah.
It just doesn't feel right.
Logs being here in the first place, I just it can't be right. Of course, I
No.
don't see how it would be. Um, oh, do I have this flipped? Let me do it. Oh, don't tell me that I flipped something. 2x plus 2y dy dx is 0. Oh, it should be minus x over y. But did I make the same mistake earlier? That could have been the reason this is bad.
Oh no, is it upside down? Oh, good grief. Oh no, is
Oh,
it
I literally
upside
just
down?
flipped it. Dude, I can't believe it. I mean,
Yeah, but
let's see
I
if it
didn't even
fixed.
catch it. I looked
Uh,
at it like 50 times. I didn't catch it. It's
let's see
supposed
if
to be
that.
x dx plus y dy equals 0.
Okay, how about
Yeah,
this?
it was upside down. Oh, good grief. Yeah, sorry, Don. I'm supposed to be paying attention here. I don't know how I messed up.
I that I shouldn't have made that mistake in the first place. Okay. Well, this is at least something to work with again. Let's scrap that work. What do we get after the denominator here? The mu squareds on top, I think, go away. So it should be just a 2r over 2r minus mu squared. Okay. And so then out front, we're going to get a 4r. We're going to need some inverse trig business to deal with this, I think. Or not inverse trig, but trig. I think this is a sine situation.
Yeah.
We want mu to be equal to root 2r sine theta d mu root 2r cos theta d theta. Oh god. Thank you.
Can I move this?
I should probably just like get
I
rid of
just
it
learned how
too.
to I just learned how to move things. Wow.
Hey. Okay, so root 2r can come out. Just a 2r can come out front. No, wait. No, a root 2r comes out front. Inside will be. Why am I doing more I shouldn't do mental math. Let's just write out our steps. The root 1 minus sine squared becomes cosine. This entire thing is going to 1, right? Or it's just d theta? Yeah, everything
Yeah.
cancels. Okay. And so theta is arc sine mu over root 2r minus root 2r to root 2r. Okay. Arc sine 1, which we can figure out. Minus 4r arc sine minus 1. Arc sine of 1.
Pi over 2.
Oh, that's perfect. Or is that minus 1 minus pi over 2?
Yeah.
Oh, that's not perfect. Maybe we have one too many twos. Or were we not supposed to have the 2 in the very front when we started?
I feel like we're supposed to have it. Well, coincidentally, you're getting 4 pi r, which is the same thing I got when I tried using polar coordinates.
Oh, yeah.
So maybe it's all right.
Well, no, it should just be 2 pi r for the circumference of a circle. The coordinate transform shouldn't matter. Um, and I'm looking for like an error in the integration. Can't find it.
I don't think we made any mistakes. It does say, do you get the correct answer? I mean, why would it say that if we did? That
I
seems to
mean,
hint that there should be a reason why we get something different.
it is the same thing as 2 pi and then in parentheses 2r, and that 2r is what is mu squared plus nu squared.
Yeah.
But
Oh,
I
wait
feel
a
like
second.
it
Wait a second.
shouldn't. I don't know. I don't feel like that's it. I think we should just get 2 pi r, unless this r is something
And,
else.
and wait a second. When we do the ratio of that circumference to the diameter of the circle, we get 2 pi times the square root of r over 2. And let's see.
Oh, we still, yeah, the diameter, if the, mm, no, I don't know. think I'm breaking down here. Unless you have something you're still thinking about, I'm okay with looking at the back of the book.
Yeah, sure.
Okay, or not the back of the book, but the answer key. Um,
Almost time to call it anyway.
yeah, number 7.
That was an interesting problem. I want to understand what's going on with that.
Yeah, same. Okay, so I guess they drew a bunch of examples of parabolas for different values of mu and nu for part A. We did part B, right? Okay, so I wish they, for part C, I wish they stated that somewhere in the chapter because there's no cross terms.
Hmm.
Um, hey, Papadoria, it's going well. We just spent a lot of time on one problem and we got it mostly right. We did part B right, or
I
D.
think well, we got it all right so far.
Yeah, and so circumference. Okay, so we have the same setup so far.
Yeah.
What? So they don't put the 2 up front.
Oh, is that where our mistake was? We had it too.
Well, I thought we needed that because we were only getting the upper half of the circle, or the lower half, or something.
So we were off by 2.
The whole circle is covered by the coordinate range mu equals minus 2r to mu equals root 2r.
The whole circle. Oh, see, that's where we were stuck with the bounds. That's the only mistake we made, I guess. We probably should have spent some more time in part D when we drew that circle and we were trying to see what was happening to points on the circle as
Guess
we moved from
so.
yeah.
Like, if I just uh like if we did some Cartesian, well, we wouldn't need to multiply by uh 2 either. It just feels wrong. What did I say? It's minus x, or it's gonna be x over. Okay. x squared divided by 1 minus x squared. Huh. So I just quickly plug the regular Cartesian version of the integral into Wolfram alpha. It only gets pi and not 2 pi for a circle of radius 1. So we would have needed the 2.
Hmm.
That's so weird.
Well, pretty good. Pretty good.
Yeah,
I'd say we get a B.
a B. I mean, yeah,
Yeah.
we only got stuck on like that last problem. We were flying through the ones before. All right, I guess good work. Um, I'm probably gonna do some googling about this because like it's just weird that we don't need that too.
Well, he did say in the answers that that was a key step, was to realize that that traces the whole circle and not just half of it. It probably makes sense intuitively. We're thinking of, the regular XY coordinate system, and we understand that we get half the circle, but somehow this transformation gave us the whole circle.
I'm wondering if the circle is no longer centered at the origin after the coordinate transform.
Hmm.
Maybe that would save it if it's completely in one quadrant. Well, no, I don't know.
It does feel, you know what it does feel like? It feels like a complex analysis question to me, a question in complex variables. And I remember at the back of my complex variables book, they have, what do they call them? What do they call those transformations when they preserve angles? There's a word for them.
So the Mobius one, or
I think that might be a special case. I forget what they're called now.
I'm trying to get back to Penn Center's class, but
Yeah, yeah,
too
yeah.
long ago. I'm pretty sure you
They're not
covered them
called
all.
they're not called isometries. What are they called? Nope, won't come to me.
Conformal maps or conformal transforms.
Conformal
Yeah.
mapping. Thank you. Yes, conformal. Um, yeah, so it feels like one of those. Like the back of the book I had like 5 pages of like graphs, and it was showing the transformation and then showing like what the curves in the XY plane map to in the UV plane. And I'm pretty sure that was one of the ones they showed.
Uh, and in Conklin, the issue that we're talking about is if you use the formula for arc length for a circle, to get the circumference, you need to multiply the integral by 2 because you're only integrating over the upper half of the circle. But for whatever reason, after you do this coordinate transform, you no longer need to multiply by 2. That's what we're trying to figure out. But I think it's going to be like, or I think we'll still wrap up the group here though for the day.
So we got through
Um,
question 7. Pretty good.
yeah, not bad. There are only like 12 in total, so next
I
week we'll start
started
on
reading
chapter 3.
chapter 3 a little bit. Did you start looking at it at all?
No, I need to get on it. Inertial frames.
The end of chapter 3, they bring in the Lagrangian. Lagrange's equation.
Oh. Uh, I've seen it before. I don't remember it.
So it's going to be a challenge.
Oh, I see. By the Lagrangian.
Yeah, there it is.
Yeah, I don't think I've seen like a differential equation like that before, but I don't know if I've seen this equation. Actually, no, I've not seen this before. I didn't realize this is a PD. Or is it? No. I I don't know what's happening there, but it'll be interesting to find out.
I think each coordinate, so the x is like the position and the x dot is the velocity.
Okay. V
And
is
somehow you
potential
somehow you
energy?
build this. Yeah, the L is like the potential, the kinetic energy minus the potential energy.
Oh.
Yeah, there it is right there. Equation 333.
Once you learn Lagrangian to
Kinetic
get your
energy
physics
minus
license.
potential energy. So that'll be fun.
All
That'll be
right.
fun.
Yep, we got that
All right.
to look forward to.
Yep. Well, thanks for coming on, Don. Actually, your voice sounds good now. You feeling better?
Mostly, yeah. Not
Yeah.
100%, but you'll be there.
Oh, well, thanks for coming on.
Yep. Thanks for being here.
Yep. See you
Talk to
next
you
week.
later. Yep. Bye. Okay. Um, that's how it seems. Color code, or like I honestly don't know. We probably need some more time, like manually mapping points to figure it out. We'll do math for a little bit. I'm still like not incredibly with it, but just give me a minute to switch things over. I mean, I might just even do some more problems from chapter one or chapter two. What music am I gonna play? I guess that one. Who cares? Oh, it's probably that Discord magic. Discord does a lot of like cleaning up of people's voices. No, it's just Discord. I wouldn't buy headphones just for that. Okay, I think we got everything switched up. Oh, I need to save a copy of these notes. Ugh. Yeah, it's definitely a neat question. Okay. Posted the notes. Get out of the Excalibur before it explodes. Oh, wrong scene. Honestly, I think I want to keep thinking about that. It's really bothering me. I'm literally just gonna do this the stupid number crunching of manually mapping points from one to the other. Oh, did you color code? That that would be amazing. Okay, well that doesn't help me at least. Mu nu and minus mu minus nu are sent to the same point. Okay, sure. So there's like a duplication there. I don't. I can sort of see why that might matter, but I don't completely see it. A half circle in the mu nu plane is sent to a full circle in the xy plane. I don't think so. If you're plugging in values from mu and nu, you'll only ever get one XY pair out. If you're plugging values in for X and Y, I can see how you can get multiple mu's and nus. Or at least as far as I can tell, you only get essential duplicate values in the other direction color cone. That's why I don't understand. Like, as only the direction that I writing up here seems like it would potentially do that. Um, God, this is so annoying though to work it out with x's and y's. But if you have a mu and a nu, you're definitely only getting one x and y back. What am I doing here? Above every point there is 2 point? I don't know what that means either. I don't know. I can see there's kind of like something there, but I can't quite exactly work out why. Yeah, but even then, I don't really want to do the thing that I was originally thinking, which is just looking at the mapping by hand like this, because these coordinates are kind of a pain. U equals 0 doesn't get us anything. Hey, Silverbird. If c is u plus iv, then z squared equals u squared plus v squared. So z over root 2 squared. Wait, I need to rewrite this. Uh, so wait, what is this? Y plus ix. Okay, yeah, that makes sense. What is this saying, Finbox? I don't know. I think it's fine. I think I'd rather just come back to this another time now. Scaling by root 2, then a square. My angles weren't changing. Just scaling by root 2. I guess I know I I think I'm too terrible with complex numbers to understand why that's saying that. Um, sorry, I was just debating like what else I. Okay, so I'll explain what the question is, but I kind of just want to not think about it to be honest. Or I don't know I just I can't figure out how to put it in my own terms. I guess. The problem it originally like we already solved the entire problem. Uh, well, nearly. The issue was that in part E we were off by we had an extra factor of 2 because at some point we made an integral and we multiplied it by 2 thinking that oh if you use the arc length for with Cartesian coordinates to get the circumference of a circle you need to multiply it by 2 because you're only getting half the circle. For reason after applying that change of variables you don't need to multiply by 2 anymore. Um, and it the answer key like says it's kind of trivial, but the like I don't know. There's been calculations that have been put forward. They don't make sense to me, but that that's basically the issue. I think I am gonna feel stupid with a different type of physics problem now instead. Where did I leave off? I need to find. I left off on number 4 a long time ago. Did I actually do it? I think I did it in a sketchy way, but I'm just gonna say that I did it. I'm gonna grab number 5. Dividing polynomials? Not that worried. If synthetic division looks weird to you, that's because it is weird, and I don't like it. There's like two ways they normally teach it. There's like long division and synthetic division. So if you do encounter, I mean they're both a little bit weird, but synthetic division is just really out there. The last problem's number. It it's number 7, part E. Specifically, why don't you need a 2 in front of the integral when you're calculating the circumference? Beating off to GTA Online. I guess there's strip clubs in there, but I was like, okay, yeah, that's fair. When I think of GTA, I think of like being on the run from the cops and stuff. I was like, why would you beat off to that? Gravitational torque on an object with mass m. We treat it like a point mass m located at the cm. I feel like I'm gonna get owned by this one. I want. They talked about this a little bit in the chapter, right? R cross f. This really trips me out about torque. Like, why why is it the cross product? I feel weird about like I don't know what that physically means. So I'm just imagining like you pushing down on a lever. The force is down and it is still down, but like the torque is coming out perpendicularly from the lever, which is weird. I don't torque enough. Yeah, I guess it's just like the direction of it that weirds me out. Ignore the fact. Oh, I guess in this case, you can ignore that it's a vector and just deal with the magnitude. Okay. So the multiplication makes sense with the math. Oh, okay. I mean, I guess that's fair just to get a direction that probably has nice properties. T6 comes here. Oh yeah, I think I heard that. Okay, so I assume we're gonna need some kind of integral. Do I don't know. Well, yeah, the ratio is pi. The issue is that when you go to actually set up the integral to calculate it, we we put a 2 in front of this integral, just thinking for the step of finding the circumference. We put a 2 in front of this integral, thinking it's needed because if you do it in Cartesian coordinates, you sure as hell need that 2. For a reason, in the mu and nu coordinates, you don't need the 2 in your arc length integral. And so that's what the question really was. I mean, I don't they want you to get the circumference of a circle with integration. How else are you, like that's at least the task that they want us. Oh, thank you so much for the Prime Fitfin box. Holy crap! A new Greek letter. This is from the answer key, but they're basically asking us to like verify that the circumference works out to be the same, regardless of coordinate system. Delta delta delta. Mm-hmm. Something is overrated. uh, I mean, a lot of streamers oversell subs, or especially like with Prime, that like streamers will say some weird things to sell Amazon Prime or Twitch Prime. But I know it's always been more about like wanting to support the person than you getting all that much back in return. Hey, Papadoria, bidding is underrated. I don't know what that is. Um, A weird question I haven't seen before? Sure, Papadoria. Get some streamers you don't follow. Oh, yeah. There's some kind of like loose priority system, but you can get subs for like completely random streamers you never seen before. Sounds good. How's this? I'm still debating if you want to use an integral or a summation for this. I guess you probably need to use a summation. Integral just seems weird. I don't know how exactly it would be used. So the gravitational torque on an object of mass m treated like a point mass m located at cm. Small hot and sour soup made you full. Oh, nice. Is it R sub I, F sub I? Oh, cross. Yeah, duh. I, this hmm. Gravitational torque on an object of mass m. Oh, okay. Papadorius tended. Let's see. Postman denotes the nth number less than -1, such that f of on equals 0. X equals x, choose x inverse. Wikipedia, wait to get it again. Nice. Prove that the limit of a sub n minus 1 minus a sub n equals 1. Is this some rephrasing of like the Riemann hypothesis or something? We have to be careful of that with Papadoria problems. That's like a legitimate concern. Um, You just told everyone about it. That's true, Cytos. You graphed it? Okay. It's true? Okay, okay. Uh yeah, Fenvox. It is X choose. Oh my gosh. Choose has an H in it. It's like a binomial expansion. It's the nth number less than -1. Okay, so this is so weird. So like if we were to test -2, for instance, we would need to test if -2 choose -1/2 is equal to 0. Um, and how I need to remember how this works again. I learned about this especially in like Zach's class, and I remember like seeing the pattern and being satisfied that I found a way that I could remember it, and I don't remember it. Choose with rational numbers. Ugh. Oh, okay. I mean, uh, it's a neat thing to see for Desmos. Oh yeah, -1. Uh, okay, and it's working at the. We're only taking the ones where it hits 0. Yeah, okay, and these should, as n gets very large, they should be spaced out by 1. They're already pretty close to being spaced 1 apart. That's almost exactly 1. Okay, yeah. Okay, so visually that's what's happening. And why doesn't Google just show me the thing that I'm actually looking for? Hey, boss, thank you. um, what's the thing that I'm? If I just look up Venom Fiction, is that going to show me the choose with? Here we go. Big year old math. Yes, whatever that means. Empire. For times table, just practice it a lot. I'm getting lost in how you actually would calculate it for a particular number here, but maybe if we can just bash it out with the formula and try not to question it. It's so weird. Like, how do you even get this? I don't know what difference to set up. I saw that jazz soup. Like, I don't know what to do with that. I don't know what two elements to choose though. That's the issue. Like we need to somehow assure ourselves that they fulfill that condition. And like I don't know how you do that. The denominator must be zero, Salvadorian? Well, the denominator being zero wouldn't be good. In the denominator of it's going to also involve factorials, is it not? See, I've heard that before, so I forget what the thing about it was. Yeah, I'm sorry. I have no clue. If someone wants to, or if someone finds something, then it is posted in the Discord. When Dawn becomes infinite. Oh, okay. I just really, I really don't want to spend another 45 minutes staring at a problem. I've been doing that all stream. But it is posted in the math homework help forum in this thread here. So yeah, I'm sorry, Salvador. This one is way too out there for me. I'll say I think I'd rather just end the stream. So I'm getting kind of just mentally tired. Because even the physics one is gonna take I don't really know where to go with it either. So yeah. Um, let's just wrap it up here. So yeah. Sorry to cut you short, pop Doria, but yeah. I'll wait for next week. I'll be back on my regular schedule, so back on Tuesday, hopefully. But yeah, I'll see you later, YouTube, and then I'll just look for a raid.